So in the previous video, we were given two integers a and b in C, and we were able to find the GCD between a and b by applying the division algorithm several times. In this lecture, we're talking about the extended Euclidean algorithm, and what we want to find is solutions to the equation GCD equal xa plus yb. So we want to find the x and the y that solve the solution. Before we learn how to do that, notice that solving an equation m equal xa plus yb is not easy, and in fact it doesn't have a solution a lot of times. Recall that when I talk about solution, I mean integer solutions. Notice that when I look at an equation in several variables in which only integers, additions, and multiplication come up, it is called a Diophantine equation. Diophantine equations are pretty hard to solve, and the extended Euclidean algorithm is a very powerful tool to solve some of them. Let me give you a couple examples. For example, the equation 3 equal 2x plus 4y will never have a solution among the integers. One way to see it is an argument that we already have given in class. Whatever x value we give and y value we give to this equation, the quantity on the right will be even because each x is multiplied by 2 and y is multiplied by 4. And the quantity on the left is odd. So there is no way we can find an x and a y that will verify the equation. However, if we look at the example 44 equal 2024x plus 748y, we can see that the numbers x equal -7 and y equal 19 are actually solutions of this example. Now, so we do have an example where things don't work out and an example where things work out pretty well. Now you might recognize that this 44 is exactly the GCD of 2024 and 748, as we have discovered before. And you might wonder, how did we find the solution -7 and 19? Let me do that in the next slide. So I rewrote from our previous work all the division steps that we took to find the GCA between 2024 and 748. And I stopped one step earlier because I know that 44 was actually the GCD, and the next step will give me a remainder of 0. So this is stuff we have already learned. The next step, the new step we want to learn is that we are going to write all the remainder in terms of the divisor and the other number. So, and this one, 528 is 2024 minus 2 times 748. Then 2020 is 748 minus 1 times 528. And then 88 is 528 minus 2 times 220. And 44 is 220 minus 2 times 88. So in this writing, we'll notice we are going to remember that we are not going to multiply out things that are remainder. So 88 is a remainder, 220 is a remainder, 528 is a remainder, and at the end we're gonna want to look at what happened to 748 and 2024. Let me explain you what I mean. We have these four equations, and we're gonna look at those four equations from the bottom up. So let's rewrite this last equation. 44, 220 minus 2.88. The remainder, the next equation, has 88 written in terms of other two remainders. So we're gonna replace our 88 with the equation above. So here we have 44 equal 220 minus 2, 528 minus 2 times 220. Now we have seen that we have marked that 528 and 220 are remainders, so we are not going to multiply those out. We're gonna leave them appearing in our equation. So I'm gonna have minus 2 times 528 plus 4 times 228. Then I'm gonna group the two remainders that are the same to have 5 times 220 minus 2 times 528. Now I have 44 written in terms of two previous remainder. I noticed that in the second equation, the remainder that gets written out as previous remainder is 220. So I am going to replace this 220 with the previous equation. Let's do that. I have 44 equal 5 times 748 minus 1 times 5 to 8 minus 2 times 5 to 8. Again, 748, 5 to 8, and 5 to 8 are remainders, so I don't want to multiply them out. So I'll write 5 times 748 minus 5 times 528 minus 2 times 528. I will collect together the common remainder, 528, to have minus 7 times 528. Now I notice that the next remainder is actually 528, and I can write that in terms of 2024 and 748. So what I mean is that this remainder is going to be written in terms of the first equation. I will do that to get 44, 5 times 7, 48 minus 7, 24 minus 2 times 748. Now it's 748 and 2024 are actually the number I was interested in. I'm not gonna multiply them out. I will just write 7 times 2024 plus 14 times 748. I will collect together 748 that appears twice to get 19 times 748 minus 7 times 2024, and this will give us our solutions. This is the equation that I was looking for. My x is -7 and my y is 19. This could look at seem an overwhelming process, but truly once you do it a couple of times and you try not to multiply out, recognizing the remainders, you will see that's just a matter of substitutions.